Hey there! Today we are going to do day 4 of Advent of Code 2022 and we're going to do that in JavaScript. Let's get started with the first problem. Camp cleanup. Yeah, so I've read already the problem statements and we have a list of intervals, and actually one thing I wanted to check, the intervals can be big numbers. So first of all, let's just take this and paste it into our local file. We can here modify our template that it reads from this local file. We need to split a new line, and then yep, that's it. We just split a new line. So I think I should remove this map number from the template because we haven't been using it 4 days in a row. So yeah, maybe it's not useful. Part 1. You know what? Let's just do parsing first, and then we think a bit more about the logic and everything. So here we're just going to do a map because usually it is a good thing to do the map. Res, and here we console log the result. What do we do in the map? In the map we need to split on the comma. So const, what do we call that? We call that interval 1, interval 2, and this is a line that's split with the comma. What am I doing here is I'm destructuring the array into 2 variables, and then for each of these variables we can split with the dash and parse int. So maybe I just keep that an array, or better than that, we actually do here a map. Interval, and here we return it's interval that split with the not the comma but the dash now, and we map number to make sure we convert that from a string to an integer. I think that looks nice. So what we do is we're just gonna log that to make sure we have something correct. Node day4.mjs. Looks like we have parsed the data correctly. So parsing is half the problem, but maybe the less interesting half. Now we can focus on the most interesting half, which is solving this. And basically we have intervals, so we need to make sure one of the 2 intervals is inside the other interval. So here there's a good visualization of the intervals. So what we can do is we can so the first thing, let's say, so I'm just thinking there are two configurations. Either we have this one as the first value and this one as the second one, or the reverse. So we need to I think we're going to sort them by the first element. So that's going to remove one edge case. So here we actually do dot sort AB, and here we do A of 0 minus B of 0. So we sort them by increasing first value. Let me pause a second. Okay, I just had to close the door for less noise for the video. So yeah, here we would like to see the reverse for this specific case, and the other shouldn't be touched. So let's see what's happening here. Yes, we have 4, 6, 6, 6. So this is making things a little bit simpler. Now we know that this value is less or equal to this value. And now we can check const. So because this one is smaller, we need to check that interval 2 is inside interval 1. So 2 is fully inside 1. That's a very long variable name. Let me double check. This is what they say, fully contains the other. Okay, so 2 fully contains 1. How do we do that? We just say so we know that this one is below or equal to this one. So we just need to make sure that the bigger one is below or equal this one. That's it. You just need to make sure that interval 2 of 1, the second value here, is smaller or equal than interval 1 of 1. So because we sort here, we know that this one is smaller or equal than this one, and with this we make sure that this one is smaller or equal than this one, and this means that interval 2 is inside interval 1. So let's display 2 fully contains 1. And now we need to see here, when is it correct? Let's see the results. There are 2 such pairs. And the 2 pairs are these 2. Yeah. 3, 7 is between 2 and 8, and 6, 6 is between 4 and 6. So this is correct. So we have our solution. So we need to return either if this is true, we return 1, otherwise we return 0, and now we can do a sum. And the sum, as you know, is this little reduce function, a plus b, starting with the value 0, and we have the value 2. So I think we should be good. We just have to take the full input, paste it into our local, paste it into a local file, run that again, and we have this value. Let's see, this is not the right answer. Okay, so we need to think about that again. I am gonna do 2 seconds of thinking outside the video just to make sure I'm on the right track. So what I was doing is I've been going like reading those manually, just looking if I see like something, an obvious mistake that I've made. And here I see an obvious mistake. Because if I look at my code, this one, yeah, there's a problem here basically. Because this one is bigger than this one. So I would count that as false. Because, yeah, I need to do a better sorting here. So here I need to do a better sorting. So let's do a better sorting. If A0 is equal to B0, so this is the case that we're talking about, this one. In that case, we want to sort, said if 2 fully contains 1. So we want to do an ascending sort on the second one. So we need to return ascending, so this is a minus b, and otherwise we do that. So basically here I am removing edge cases by sorting those two values. I first of all I check and make sure the smallest value is first. So in this case this would be the first value. Oh, maybe let me increase the size. Sorry, I didn't check that it would be like so small on the video. So this, and in the case this first value is the same, we need this one, this interval to be first, so that because our code is always checking whether the first interval is included in the second one. Yeah, 2 fully contains 1. So let's run that again. So now, instead of running the full thing, I will just run our edge case. This is this one. So what I'm gonna do, I'm gonna just run it like I was previously. It was returning 1. 2 fully contains 1. Okay. And if I do the opposite, it was returning 0, which is the problem that we are trying to solve. Now, if we uncomment this, we see we are not solving this at all. Let's see again. 2 fully contains 1. So here 2 is containing 1 fully. Let's actually console log interval 1, interval 2. I'm making like some dumb mistake here. Okay, so 2 should be containing 1. I think I'm making a mistake here, like 2 should be containing 1. So for 2 to contain 1, we need the biggest value of 1 to be smaller than this one. So I think I made a mistake here. The biggest value of 1 should be smaller than the biggest value of 2. Okay, so we have 1. Let's reverse our test case. We still have 1. We have, like, you see, like here we reverse the two intervals and we still have the same input. So our normalization is doing the right thing. Now we need to take again this is so big now. We need to take again the basic input and check what's happening here. We have 5, which is not correct at all, so I am doing something very wrong. That's fine, you know. I had like a nice day and I'm a bit tired, so I'm making some stupid mistakes. So I think here I'm not doing the right thing. Let's do that. Oh, I'm not doing the right thing at all here. Look, we want 2 fully contains 1. Let's just say fully contains, because I don't know, I'm not sure if this is 1 or 2. I'm going to write that again from scratch. So what we want, you know what, let's keep this variable. So if we want this to contain this fully, we need this value. So interval 1 of 0 should be above or equal interval 2 of 0, and interval 1 of 1 should be below or equal interval 2 of 1. Yeah, that's the right way to describe an intersection, is like that. You want the smallest value. Yeah, that's kind of how I think in my head. It's hard to explain it. Let's see that again. Oh. Let's see here. This should be, so looks like we're struggling. Let's do that again. Here, interval 1, we have a 4. So because of the normalization that I'm doing, this is not the right thing. It should be 1 fully contains 2. And in that case, we need to make sure this one is below or equal the second one, and this one is above or equal. Yeah. So what was happening is that I was doing one normalization to remove some edge cases, and here I was doing the intersection for just the opposite normalization. So that was not working. Still not working. 2 fully contains 1. 1 fully contains 2. So we are back on our feet with the first example. Now I want to reuse the sneaky example just to make sure we are correct. This is not working. It's funny with a simple code how all things can go wrong. So I think maybe this is not correct. Maybe the right way to go, instead of sorting from the first and the second, I think what we should do is sort by the size of the interval. So here we want the one, so the first interval, we want it to be the biggest one. So here const one size, it is a of 1 minus a of 0, because we know the values are increasing, and const to size b of 1 minus b of 0. And here we want the biggest size first, so 2 size minus 1 size. Let's see that. Yeah, it is reverting the order. We have 188 and 12. Let's try to go back to this version. It should be the same, and we go back to the default param statement. We have 2, so I think I'm doing the right thing now. So the normalization was not right, the intersection algorithm was not right, but now we fixed the intersection between 2 intervals, and we fixed the normalization to remove edge cases. We can remove that, and we can try again with the full input. It's funny how you can make so many little mistakes. Let's try that. we got it. Let's go to part 2. I'm gonna pause to read the problem statement. I'll be back in a second. Okay, so now instead of having one that fully contains the other interval, we want overlap. Overlap is basically we can take the same code and we just need to change the intersection algorithm here. So that should be simpler. Famous last words. So here it's overlap. So what's happening is we need to here for an overlap to happen. It is very simple. So this is an intersection algorithm in one dimension. So we want the interval 1 of 0. If this one is bigger or equal to interval 2 of 1, we have an intersection in that case, because that means that the smaller value is bigger than the bigger value of the other, so we have an intersection. And the other option is interval 1 of 1 is below or equal to interval 2 of 0. Let's see here in this case. So here, if the biggest value of the first one is smaller than this one, then we have an intersection. So here, smaller or equal. Let's make sure. Yeah, smaller or equal. So here, for example, this is the case. We have an intersection. And the other option is the smaller version of this interval is, oh no, I'm not sure I'm doing the right thing. No. I think we need both. Oh, that's interesting. I think I'm not doing the right thing. Looking at that. Okay. That's not correct. We need two conditions to make sure. So let's take one example here, and let's work with that. So here we have interval 1 of 0 is, so this is not this scenario, this is the other one. We have interval 1 of 1 that is smaller or equal to this one. But we need to make sure that this one is bigger than this one. Otherwise, we can have this scenario, and that wouldn't work for us, right? So here we need to say and interval 1 oh, so maybe it's just an and here. So interval 1 of 0 is So to be honest, I think this is like something that you can just find on the web, but I want to do it myself. I want to do it myself. So interval. So I think the variable names, by the way, are like very bad. So you know what? We can change it. Let's do that. First, let's do first and second. That's gonna be a lot cleaner already. So the first I'm just looking at so first of 0 is above or equal. No, that's not what's happening here. First of 1 is below or equal second of 0, and first of 0 is I feel like I'm missing something. I hate being stuck like that inside a video, but that's, you know, that's life. So we need to make sure that this one is below and this one is above this one. Yeah, that's it, that's it. So first of 1 is below second 0, and first of 0 and second of 1 is above or equal first of 0. That's it. That's, wait, is that it? Have I just done it like so we need this one to be below or equal this one, and this one to be, no, this one to be above or equal this one. I think that's it. Let's check on the, I think that's it. Do we need to check? No, we just need to check if a pair is overlapping or not. So I think that's correct. Let's check here. Oh no, 110. We don't care about the full version. We just want to debug first, just to make sure we are not in like a crazy place. We have 4. That's 4. So actually, have I done it? You know what? We just Ctrl Z to get the full data set. I think I've done it. Oh, today is a funny day. I'm making some mistakes. You know what? I think it's time to like have something I can draw on, because I'm thinking in my head and I need like something on the paper. Okay, now we have something that looks a bit better. So we have one interval and we have the second interval, and that's one scenario, and the other scenario is like that. So basically in the first scenario we want this value to be above this one, and this value to be above this one. Let's name them A, B, C, D. Basically here I want C to be below B and D to be above A. If we have that, there is an overlap. Here, don't overlap with the meaningful pair, do overlap. How many assignments pair do the range overlap? Oh, one thing that I didn't check is whether this was a bigger or smaller number than this one to better understand my error. So I think I'm going to submit again just to see my answer is too low. So I'm missing some edge cases. So let's see about this one. A, B, C, and D. Here, C is below or equal than B, and D is above or equal than A. And that's it, we have something that intersects. So this formula works as well for this edge case. Let's see another edge case where we have like a small value like that. Let's see. Cut my notifications. In that case, C is below B and D is above A. So that looks correct. There is one more scenario like that. C is below B and D is above A. Looks like we've got the right formula here. So now we need to make sure it translates correctly into code. I've translated correctly into code. So first is above, wait, A and D. So A is first of 0. And to make sure this is below or equal D, which is second of 1. So below or equal, oops, that's correct. And then here the first of 1 is above or equal. Oh, so here first of 1 is above or equal second dot 0. Yeah. Was it like just a small mistake like that? Oh, wow, this is a much bigger number, and that's correct, because it must be bigger than this one. So I think that was just this dumb mistake. Let's take the small, yeah, this is still 4. So I think we've got the right data now. So basically, I had to draw this to get the right formula. Now that I've drawn this, I've fixed the formula here. We run it. This is 903. Next time, I'm just gonna open the text. Next time, I'm just opening the drawing app right away. You know what? So yeah, today was a bit full of bumps in the road, but we made it. I hope the drawing was really a good explanation, a better explanation than what I was saying. Thank you very much for following the series. Don't forget to drop a like, subscribe if you haven't already, and see you tomorrow for the next one. Bye bye.